Okay, start now.
Oh, hi everyone. Welcome to the Phoenix Buildathon Kickoff Workshop. Thank you all so much for joining us today. I'm Hiding from AKINDO, and today's main session will be led by Lauren from the Phoenix Development Engineer. So, hi Lauren. Thank you so much for joining us today.
Hi, thank you so much for having me. Very excited to get this kicked off.
Yeah, so today's session will mainly be an introductory workshop from the Phoenix team, and we will wrap things up with a short live Q&A at the end. So, so before we begin, I'll quickly share my screen and walk through the Akindo page shortly.
Sounds good.
Okay, so as you can see here, this is the Buildathon page on app.akindo.io. So you can sign up right here and jump into our buildathon. So for anyone who is new to Akindo, one simple way to think about is this is like buildathon is a one long hackathon, and each wave is basically a stage within that hackathon. So yeah, already like many builders are sign up, as you can see. Yes, yeah, throughout the program, like builders continue to build and submit and get feedback and improve over time as they move from one wave to the next. Yes, so yeah, this is like our program structure. You can join our Akindo webpage, and then you can just simply look through these wave sessions. Okay, so today I'm very happy to hand things over to Lauren from Phoenix. So Lauren will walk you through what Phoenix is building and why confidential computing matters and what builders should keep in mind as they start exploring ideas during this buildathon. Okay, so Lauren, could you lead your session, please?
Yeah, absolutely. Let me go ahead and get my screen shared and we'll kick right off. All right, cool, cool, cool. So today I'm going to be talking about how confidential UX implementation can unlock new markets that previously have been unavailable to us. So, quick intro, I'm Lauren. I am DevRel at Phoenix. We are building confidentiality infra for the EVM, so let's get into it. All right, so let's start off with the problem that we're aiming to solve here. What's at play? So the systems that we're familiar with in the Ethereum ecosystem were architected for transparency by default. This means that when the early days of Ethereum came up, transparency was actually seen as a benefit and I suppose a plus in the column than an actual thing that we were trying to fix. So we've seen this shift a little bit throughout time, and I think transparency still ties deeply into the ethos of the OG Ethereum days, but we started to see that with transparency comes certain downsides. So I'll get into a little bit of what that looks like and how we can maybe aim to make some changes around it. Okie dokie. So a little bit of an extension on that. Ethereum as a whole is a glass house. All of the state, the public state, is visible to the entire network. And this includes things like balances, your votes, your bids, any user preferences that have been indicated on network, and all of that behavior. So the results of this ultimately is the sensitive data in any interaction is going to be leaked, inviting MEV exploitation. So there's actual capital deficit happening here, or your full strategy can be exposed and copy traded. Um, this has kind of become something that we have just grown to accept. It's like the invisible tax. It is something that we just feel like comes with the territory. But it's been interesting to start to look at this work and say, well, maybe it doesn't have to be a given. So, just another side note here that there are some existing methods in addition to what we're working on at Phenix. We have ZK, MPC, but we noticed that there's some limitations here as they don't support that same encrypted logic with persistent state. All right, so I had mentioned earlier that this is not just an inconvenience at this point, this is a capital deficit. And so we look at it in terms of numbers. It is a roughly $500 million problem. So these stats are from 2023, and we saw that MEV losses in DeFi did exceed that. And I think the other interesting piece of statistic that came out of this work was that the majority of people being affected by DeFi were not the multi-million dollar whale traders or the first time users. It was actually more of the mid-level retail, like, repeat user, which I found interesting. So, yeah, I mean, everybody is equally affected though. Let's see. So we also saw up to 40% auction value extracted, and yeah, that's crazy. That's almost half. 75% of the losses were from trades under 20K. So we can sum this up to say that the public auction parameters equal an exploitation that becomes predictable. And as a more of a side note, as we continue building in the age of AI, the agents are getting smarter as we are also getting smarter, and that means the exploits and the predictability are becoming much, much easier. Okay, so why is the time now to start having this conversation? Um, yeah, I guess the window has been open for like a hot second only, but in 2023 time, we noticed that there were solutions, there were ideas for how can we approach this fix, and none of them felt technically ready enough. FHE was still a bit slow. ZK had been used a little bit here and there as almost like use cases. There were certain implementations that we thought had promise, but there was just no backing to them yet. So we flash forward a few years, research and development has been pushed heavily, there's been progress made, and now we see that, at least in the FHE side, private shared state is ready. So we can, confidently say fully homomorphic encryption is ready for the majority of use cases that make sense for it today. So technical blockers are no longer the case, and we look forward towards 2026, where the protocols begin to ossify out, and we'll start to see that because privacy is relatively easy to integrate and relatively demanded by a large population, it will become more or less of a standard in early DApp building, and we are reminding gently that it is much, much easier to build a confidential by design application than to retrofit it into the stack much later. So we look at this really in a full spectrum view, that it's a requirement for institutions, it is demanded by traders, and it's non-negotiable for compliance reasons. So a little bit of an extension on that, we have the perfect storm of timing happening all around us right now as well. When we look at the stablecoin madness, there's adoption happening at an unprecedented rate in crypto. We see institutional demand, and we know they will not deploy on transparent rails. Obviously, institutions had private systems. They've had privacy in every area of their day-to-day operations for as long as they've been working. So the idea of them switching over to a public system is just, it's not in the cards. So the institutions do demand better systems, which inherently include privacy. And then lastly, we have the regulatory pressure. So a lot of the push toward FHE specifically is to say, we need flexibility around who can see encrypted data, because I don't want the whole entire world to see it, but I do think the auditors might need to see it under certain circumstances. So how can I programmatically say who can see what under what circumstances? So all those things. All right, so taking a step back here, there are a handful of those markets that now, because of access to confidential UX, we have pretty much at our fingertips and ready to build. So the first one would be that capital protection. We got into a little bit with the institution piece. And a more concrete example of that is they cannot come on chain unless they can make private payroll payments. I mean, and this example I think is funny. It's used a lot because, you imagine if the company you worked at, your payroll was public, it was on chain, it was printed out and hung by the bathroom, right? Like, this is pretty much what's happening when you plan to pay an entire organization on mainnet. So yeah, this includes the treasury and the contract payouts, and it all exposes strategy. So not only is it breaking user data friendly policies, but it is exposing your strategy, which is going to inherently leave you open to obviously this copy trading or just general competitive disadvantage that will be a lose in the long run. Next would be RWA compliance. I've seen a huge increase in projects building around this and solving for this in the last few cycles, which is really exciting. We've seen everything from escrow. I saw an electric grid project using encryption. So there's a lot of different things going on here, but I have a specific example saying real estate ownership, valuation encrypted. So this is important to think about because these transfer restrictions that you can add programmatically beforehand can also be managed on the decrypt side. So, the rules and the regulations set into place will be cross-checked over and over before the decrypt actually happens. Whereas in a lot of what we're seeing in traditional flows, the thing happens and then it's reported as malicious or then it's tried to made better. But by handling some of the programmatic policies ahead of the time in the contract, we definitely save a lot of headache. All right, and lastly, I have strategic coordination. So imagine here, you make a multi-party deal and individual A, B, and C are all able to coordinate and collaborate on this deal. They're able to bid, they're able to negotiate, they're able to go back and forth a little bit, but all of those details remain hidden until settlement. So this really opens up an entire new window for institution M&As, large trades, really unburdening a lot of the risk that currently exists for that market. All right, so remember, waiting to retrofit is not the answer. If you build a confidential by design application from the ground up, you have the regulatory piece intact from the design in the beginning. You have selective disclosure from day one. You will not be Frankensteining pieces of applications one to the next, creating immense amounts of technical debt, user migration. It basically just becomes a game of catch up forever and ever. So, all right, let's take a deeper dive right now at the current landscape of privacy enhancing technology in Ethereum. There are a handful of options here, and each are better suited to a different purpose. So we'll begin with TEEs. We have trusted execution environments are basically isolated pieces of hardware. They run code in a private instance, and they're able to manage all of this data in that same private instance. So what is the clear benefit of this? They're fast. They're really fast. Genuinely a lot less overhead than when we're thinking about cryptography. Sorry, I lost my screen. Okay. One of the main limitations of TEs is that you have to actually have trust in the hardware vendor. So obviously hardware is a little bit finicky. We know the common limitations, but these are vulnerable to side channel physical attacks. Very difficult to audit as well. So some ups and downs of that. The next I'll move on to is called multi-party computation. So this is when you just distribute the computation across multiple of the parties without revealing the individual inputs. So this distributes it in such a way that it's able to remain private inherently. Now, what is the clear limitation of MPC? Coordination is hard. Anytime you introduce more and more, you have to account for that, and it creates the overhead. So the upside, though, is that it is a reasonably secure way of managing private data without the trusted hardware component. Okay, then we have zero knowledge proofs. These are likely the most famous. Just about everybody has heard of and maybe even worked with one by now. ZK is excellent for proving that a certain set of data exists or that it meets a certain set of requirements, but it cannot handle the compute. So it's good for, let's say, individual or single-use privacy rather than consistent shared state privacy. Let's see. And then that lastly brings us to FHE, where I'll spend the bulk of the time. FHE is an encryption mechanism that actually allows the computation to happen on encrypted data while it's still in its encrypted form. So the clear benefits of this is that you don't have to decrypt data to do things like comparison, like to run the addition. This is really important when we start to talk about DeFi because you have to run the numbers, and you don't want to always decrypt, make them visible to the network, and then re-encrypt, because not only is that leaking privacy, but it's very expensive. So we'll move on. Fully homomorphic encryption. So it's a very, very long word. Let's break it down by its Latin root. We have homo, which means the same, and then we have morph, which means to change. So encryption that changes the plaintext into the ciphertext structurally the same. So because of the fact that they are structurally identical, you're able to run these operations one and then the other, and they are able to come out in the same capacity. So the data flow, from start to finish, transit and processing will be encrypted through the entirety of the process. Now let's debunk some FHE misconceptions. All right, so first one that I hear all the time, FHE is way too complex. The SDK is actually relatively easy. It uses a very familiar pattern like WAGMI. And then if you look at the Solidity side, if you have ever worked with the UINT, it's going to be relatively the same, except the EUINT. It's just the encrypted version. So, thinking about the tooling stack, between Solidity, Hard Hat, you have TypeScript, like all of these things are familiar. So there's not a huge new language, new chain learning curve. Let's continue. So too slow. All encryption is on the client side, and we've been running benchmarks that show some milliseconds. We have made immense amounts of progress. FHE is not production ready. Today we are live on Sepolia, Arbitrum, and base Sepolia. That maybe an individual or an application builder is thinking, our users don't need privacy, or they don't really care about that. Well, 75% of MEV losses hit trades. That's the stat I mentioned earlier. It tells me that your users likely do care, whether they know it or not. And then the retrofit trap, we'll add it later. Institutions are evaluating this now, and it's important to take advantage of the first mover capability, right? To be the project with a competitive advantage bringing this to market. All right. So CoFHE as a whole, we reference as like a thing, but what it really is an entire suite of developer tooling. So I went through this a little bit, but just a high level, we have the smart contract, which is the Solidity library. We have the client side, CoFHE SDK, which we actually announced CoFHE SDK this week. So I will link the documentation and everything below, but we're very excited about that. It comes with a new range of speed improvements, UX improvements, better multi-chain support, and we'll continue iterating on it. So very exciting. And then we have the mock contracts for testing, so you don't have to directly hit the threshold network itself. And then lastly, that threshold network is our state-of-the-art decryption machine. It handles with multi-party computation. So imagine that the key is split to multiple nodes, and it will never be fully recreated, which means FHE encryption and multi-party computation on the decryption side, you're covered end to end. All right. So let's take a look at an example of a Solidity contract here and see what we're working with. So just as a high level, we'll go through this block of code. The first thing that you're going to do is import fhe.sol library. So this is the core library from the Fhenix contract. And it looks like this. And then you see where we start to initiate our variables. We would here have a uint 64, 128, whatever size you've chosen. You'll put that here. You switch to the EUINT, and then we'll run our operations. So let's see for here, for an example. Oh, sorry, forgive me. Before the operations, there's a really, really important piece that cannot be missed. So this FHE.allow list, we'll talk about that in the next slide. But this is a super critical piece of code here to say, hey, I am actually accessing this variable, this contract, or this user, access to interact with this data. So if that access is not given, your next operations will fail. And then we see here the very first example of what an operation looks like. So it's just simple fhe.add. You take the two encrypted variables here together, and then you add the access back. So really, this is hyper intuitive. I mean, in Solidity, where you would have had variable plus variable equals result, now here we have FHE.add variable variable. Or there's a number of ways you can implement this, but yeah, relatively straightforward. All right. Okay, so let's talk about access control. I think that this is one of the most exciting pieces of the CoFHE stack because a lot of cryptography primitives have, very binary way of giving data. You can either decrypt and then everybody can see everything, or you leave it encrypted and nobody can see it. You can't just like peek at it a little bit. So FHE kind of flips this on its head because we can say, no, not only that, but you can see who can see the data, when they can see the data, for how long and under what circumstances, and exactly which elements of the data. But this person cannot. And I think that's so very cool because we are all building privacy right now with client compliance in mind. And to be able to say that there are steps we can take to build for regulators, for auditors, that we can give them access to these contracts, that we can be properly audited without breaking privacy across the app logic is so, so, so cool. So yeah, take advantage of this, take a look at it. Also, I mean, don't forget, allow this must be used or the code will break, but we have additional resources that I'll provide also in the chat. Anyways, I will continue. So let's talk a little bit about what you can compute on an encrypted value and maybe a brief look at what you cannot compute on an encrypted value. So the normal things, right? We talked about addition. We looked at an example of that. Arithmetic is easy. Comparison also relatively easy. We have equal to, less than, greater than, less than or equal to, greater than or equal to. You're going to just, run these comparisons. And then the contract will check whether the two encrypted values match without decrypting either one. And this is important because it's a little bit, tricky. You think about comparing encrypted two numbers that are encrypted, right? And you have encrypted A and encrypted B. Well, you can't really compare those two side by side because you don't know what's bigger. You would have to decrypt, or you'd have to have a permit. There would have to be a way to do that. So that's where we lead into selection. And select, FHE.select, is a unique part of our library that allows us to kind of work around some of these clunky pieces where we say, hey, we really need to work with this data, but we can't see it, so we can't evaluate it. How do we handle that? Select comes to the rescue. So basically you would say, if this is bigger than this, or if A bigger than C, then blah, 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 blah. .select is where it would actually choose the proper answer without evaluating one or the other and leaking gas on accident. So I guess the branch that is chosen would leak to the network. And so by being able to say, just select the one that meets my parameters, you're able to mitigate that in advance. So it is a very cool feature. And then lastly, randomness, FHE.random, to compute any randomly generated integer. All right. Okay, so new to our new SDK, we have migrated over to a path or a system with two different decryption paths. So if anybody's familiar with the CoFHE stack, how it previously was, we used to have unseal and decrypt. This was kind of differentiating between what was happening on the client side and are you decrypting the data in the contract side. And so this will do a relatively same thing. So we have view decrypt, which is going to expose the value in the UI. And this is important, like, imagine a user flow where I log on to the app and I do want my balance to be encrypted, but I also want to be able to see it whenever I want. And if you, do a whole decrypt, there are many complexities that could be introduced there. But yeah, so this just checks the access and the permits, and then we'll decrypt it on the client side. And then, the user is able to see that there. Let's see, transaction decrypt. So this is going to be the heavy duty decrypt, which allows you to actually interact with it. Then you'll be able to transact with it. But the decrypt for transaction will check the permit as well, and then it will decrypt on the contract side. Okie dokie. So we can look here at the overall life cycle of an operation through the Fhenix network. We have first, the user encrypts on the client side, they submit in the contract, then they will compute, and then the optional decrypt through the threshold network or with the decrypt view. So this is the broad picture view. All right, everybody, thank you so much. I have added 2 QR codes here for the integration deep dive. If you'd like to chat with me a little bit more about what implementation looks like, how to get started building with this, contract design, anything that will be helpful here. And then the Buildathon TG is here. So go join that chat, tell us your ideas, ask questions. We're all excited.
Okay, thank you so much, Lauren. That was really helpful. So we'll now move into a short Q&A session. So if you have any questions, please drop them into the YouTube live chat. So I'll go through the chat and ask a few questions on your behalf. Okay. So 5A62. My question is whether I could implement a more private solution for menstrual cycle tracking apps and thus avoid data extraction.
Yeah, I've heard of something like this before. I think the logic absolutely would work. It makes a lot of sense. Um, it's a great idea too. I know in this political climate, it may be needed.
Um, okay, so next question. What about like real world data executions?
Real world data exclusions.
Mm-hmm. Yeah, the question by like Surah Jade deploys.
Sorry, one more time.
Oh, I think like he was asking like about some like real world data executions like when they do making some DFs like on Phoenix.
Oh, that's a good question. So lately, I've been getting asked a lot of questions about using FHE to protect sensitive user data, but then building for encrypting something like the name and the I don't know, specific pieces like that. So I think Phoenix FHE as a whole is not designed for encrypting data like that. So I mean, it's already like reasonably hard to encrypt a string, but why would you? Because the benefit of using FHE is that you can compute on it, and you're not going to compute on a string. So yeah, I think thinking about the data that really needs to be private is important for the design of the application, and then prioritizing encrypting data that you're going to operate on.
Hmm. Okay, thank you so much. So is my question then like for builders who are completely new to Phoenix, like what would you recommend they focus on first after today's session?
Yeah, 100% the docs. I think we have, pretty thorough documentation, if I can say so myself. And we have a few like tutorials, getting started guides in there. So I would say just start to work through it. We also have a showcase team at Phoenix that's done a different demos, and there's maybe 20 in there now. So all of those show a range of use cases, different implementations, and they were built by the Phoenix engineers themselves. So I would also for sure check those out.
Hmm. Okay, thank you so much. So more questions like on the live chat. For decryption, you mentioned it happens on the client side. Does this use the user's wallet directly, or does it have its own separate keygen logic?
Oh, good question. So there is a permit generation on the client side as well. So anything is going to check that the permit is going to like do checks and balances on that. However, that permit and check will take a signature, like I believe it's like sign type 712. So that would be message.sender. Yeah, it would check from the address.
Hmm. I think like from the same person, like 9226. Also, is the infra deeply tied to EVM, or are we looking at further support soon?
We are deeply tied to EVM right now, but we'll maybe one day hopefully be Solana supporting. It's on our roadmap.
Hmm. Okay, thank you so much. So yeah, like next question. There are so many questions actually. Oh, This is maybe a little bit difficult question, but like, how can you just get the necessary privacy through Phoenix? Like, because most DS may have a weak security patch on their end. So,
Sorry, how can you get the necessary security?
yeah, how can users get the necessary privacy through Phoenix? Because most the apps like may have a weak security patch on their end. So, yeah.
I don't think I understand the question. I'm sorry. Could they send
Um,
a little more context in the chat about how can they get the necessary privacy? And
a green DM. If you just listen our like a live, can you like make more context if you want to ask like this question? Okay, so then. mm, so it's my question. So I think like one thing many builders may still be trying to understand is what makes a strong Phoenix project. So for example, like when you look at submissions, like what makes you feel that a team is really using confidentially in a meaningful way. So instead of just mentioning privacy on the surface.
ooh, that's a great question. So I first, there's I guess a few layers here. First, it's about the idea. When we see projects that we really like, it usually follows. We integrated privacy into the application because of this, and it's like, wow, that is an actual problem. That's something that needs to be solved. What a cool use case, right? So like we immediately see that protecting that data would actually solve a benefit to the app flow. And then second of all, looking at the code itself to see that anybody can import the FHE.sol library and then not touch it. That happens. But we want to see that the data that you encrypted was thoughtful, that the way that you computed on it was necessary, that you were accurately managing the result of that. Like, we want to see that it's a critical component to the overall flow and logic rather than just bolted in somewhere for shows.
Mm-hmm. Okay, thank you so much. So I think like maybe for builders who may find FHE or confidential applications a little um, intimidating at first. So how would you suggest like they start thinking about ideas in a more practical way?
Oh, that's a good one. Yeah, and especially because there's so many different directions you can go. But I will say we are primarily excited to see like consumer facing applications. What can be done? What does this confidential UX look like in practice? So that's the first one. Um, think about something that can be used because actually, surprisingly, not a lot of things can be. And then I would say, as far as ideas go, we've already dropped a bunch in the AKINDO main platform. So, we talked about what we're looking from on the sides of payments and DeFi through governance and RWAs. But yeah, if I had to narrow it down to two things that I'm really hoping come out of this buildathon, it would be more RWA use cases and then anything agentic. I know that's likely not surprising because everything right now is agentic, but we see so many overlap points for in adding just a little bit more privacy to that agent to agent workflow, and not a lot of people are building it, so the whole world is an oyster.
Mm-hmm. Okay, so there are more questions like from our chat. So Flow 637, like this buildathon is it mostly focused on the apps that deal with finance only?
Not at all. No, we're happy to see any range in any category. If you're thinking analytics, if you're thinking something specific, I mean, actually, we've seen quite a lot of DeFi. So, obviously, it's an area that will impact hugely from privacy. But I am very eager to see some new projects. So.
Mm-hmm. Okay, so like LWA, like agentic or like DeFi or like anything like interesting.
Mhm.
Mm-hmm. Okay. So, so what developer skills do I need to learn Phoenix? A high level of experience is required by 5862 user.
I would say no. I mean, and that's depending, right? Because if you're a Solidity developer, then picking up the Phoenix logic is going to be relatively straightforward because, like, think the slide that we went through before, where you see that it looks pretty much the same as a contract that you've worked with. The big caveat is that you're going to handle comparison differently. Certain things are going to work a little bit different, but overall, it looks very, very close to the same. So if you've written Solidity, you can do Phoenix.
Mm-hmm. Okay, thank you so much. And so my other question is like, do you think the most exciting opportunities on Phoenix are in crypto native use cases, or do you also see potential in broader application like areas like beyond traditional crypto products?
Yeah, yeah, I do. And I actually, I guess I'm not the only one because a lot of Web2 companies do FHE research as well.
Mm-hmm.
And I think that'll be interesting to see how we're kind of working in parallel. Like the crypto people are researching FHE while the TradFi, like traditional researchers, are also. I'm curious about the use cases that they'll latch to eventually. But we see outside of crypto, I mean, it working for obviously TradFi, right? Correct. But um, different things like AI is an obvious one there. Like one day potentially when latency and performance improves, being able to do something like train the entire input category for the model, that would be really cool because we know we're sharing so much sensitive information with these LLMs, and right now it wouldn't be feasible to go and just encrypt all of that off the gate. So yeah, I think seeing more privacy solutions being applied to AI across the board will be good.
Mm-hmm. Okay, thank you so much. There are some other questions by Red Devil. I was thinking of like multi-chain private identity where the proof stays on Phoenix. Is there any connection like um, with other chains? Is it okay?
About the other networks that we support.
So I was thinking of multi-chain private identity where the proof stays on Phoenix. Is there any connection like live with other chains with Phoenix right now?
We're live on Arbitrum based in Ethereum Sequoia.
Mm-hmm. Okay, so many questions like following questions. Yes. So is there a ready-made guide for using the Phoenix documentation with LLM AI to develop a project?
Yes, and we do have a build with AI section in our documentation. Bear with me for the next few days while we get this updated because, as I mentioned, the CoFHE SDK is new. So a lot of those resources will still be pointing to the old CoFHE JS, and that will be deprecated here pretty soon. So yeah, use it, but make sure that you're being mindful about using the new SDK. And then I'll have that update pushed shortly.
Mm-hmm. Okay, thank you so much. And also, are you live on the base L3 Horizon as well?
Are we live on the base L3 horizon? No, no.
Mm-hmm. Okay, got it. Thank you. So I think we still have like 20 minutes. So maybe I can share my Akindo webpage. And Lauren, could you like little bit guide about the schedule, like our submission schedule, and like could
Yeah,
you?
absolutely.
Mhm. Okay, wait a second. Okay. Okay, this is our program structure. So yeah, we just like did onboarding event today, and then later like these are our waves. Like Lauren, could you a little bit explain like how it will be, and then also how the judgment will be? How will the judge
Yeah,
this?
absolutely. So we have the kickoff today. Awesome. Wave one is going to kick off through the course of this weekend and leading into March 30th. So the first allocation for that is going to be a $3,000 pool. Yeah, this is primarily going to serve as ideation. So we're looking to see projects that are, MVPs. We're looking to see really strong ideas here, and also really, really want to flag that during this first wave, during ideation, if you guys want to take any of that time on my calendar, send messages in the Buildathon group chat, really like flesh out these ideas with me. We're all super happy to support on that front to make sure that you have the strongest foundation to keep building throughout the program. So we'll kick off wave 2 March 30th. This will go until April 6th, and then we have a $5,000 allocation. Wave 3 April 8th to May 1st. Now it's up to $12,000. Then we'll carry into the fourth wave at May 1st, and this will go all the way until, oh, sorry, that is May 11th. Lauren missed her glasses this morning, until May 23rd, and then it'll be $14,000 allocation. And then the very, very last wave will go the 20th to June 5th. So this is going to be the 14K plus the 2K bonus. And in this wave, obviously it being the last one, we are super interested to see the projects fleshed out. So there must be the front end implementation, and guys, like, we all have AI agents. These should be clean now. There's no excuse for not having a client side like look clean and workable at some point now, because it's so easy to spin up. But yeah, so having the details polished and having the idea fleshed out, the logic in place. I love to see good documentation. So, like, obviously you don't need to write a full technical documentation, but make sure your README really includes the why did you build this, how did you build this, what is encrypted, what does the logic look like really spend time on the README as well, because being able to explain your project is almost as important as being able to build it. So that is an important component. We can scroll down a little bit to the judging criteria, and I can deep dive into that a little bit.
Okay, thank you so much. So there are like more questions now. So wave 1, wave first, like evaluate just the idea only is okay. Wave 1.
Absolutely, yeah, I'm okay with that.
Yeah, and also so the so 3K is the total pool. No, we are like not 3K total pool. We are
No, 3K is the allocation for wave 1.
Yeah, wave 1, and our total grant is like 50,000. And yes, for example, like 3K is like a first wave pool. Then how many winners will be selected?
So this is going to depend on the wave itself. Likely between 1 and 3.
I think it depends on. So how many submissions will be, and then how many like good ideas, good product will be on. So I think it's always different. Also, okay. Permission. Okay. And our building period is like 10 days, and like evaluation period is 4 days. And actually, Lauren, like, are you the one like judging the product, or are there any other like team members are doing?
Yep, primarily me, but we'll have help from everybody at Phoenix, from marketing to strategy, the engineering team. There will be lots of eyes on the project as well.
And also, could you a little bit explain more about like evaluation? Like, how will you focus on more?
Yeah, I believe there's a section on this. If you scroll a little bit, if I'm not mistaken. There should be, or maybe it was up.
Maybe up. Application.
Maybe not. I can add that in later. So pretty much when we are judging, we're looking at a number of things. I touched on the need for privacy. So we want to see that you are using privacy to solve a problem, that it's not just like, hey, I built this thing and this can be private and that's cool. It's like, yes, it is cool and that is important, but we really, really want to see the power of using privacy to unlock problems that we're having in the space. So that will be the first component, just the necessity of the integration. Then the next will be the novelty. So there are, a handful of projects that are very important to solve for and are going to, still wow us. But we're definitely looking for projects that we have not already seen. So if this is a really creative idea and a creative implementation, that'll be bonus points as well. We are now looking for the technical complexity and the accuracy here. So we would like to see that the contract was designed in a way that is structured. It's not leaking data, that it's not, kind of a little bit mismatched. You're not referencing the old SDKs or the old libraries anywhere, that this is, technically intact and the logic makes sense. Let's see. And then the last one will be the overall presentation of the project itself. So this includes the README that I was talking about. This includes, the packaging of it. This is the front end and what does that look like? How's the user flow? Is it intuitive? Does it make sense? All of those things.
Mhm. Okay, thank you so much. And yeah, like maybe I can ask like some more questions. Like, so you are dev engineer. So from a developer perspective, like where do you see the most onboarding friction?
That's a good question. Um, that would have to be the mental models around FHE we briefly touched on. So I flagged a few times, right, that if the contract is not given access, if the ACL isn't implemented properly, this can throw a lot of errors. And this is also something that I think is one of the big hurdles for developers learning FHE for the first time, because it's just a new mental model, right? This is not something that you have to do in normal Solidity. So when you're working with Phenix, it's something that you have to start thinking about, and it's a little bit easy to forget sometimes. So I think ACL as a whole is one of those first points. And then the additional mental models around working with encrypted data, right? Like not being able to do comparisons or branching in traditional paths. That is, something that we're used to doing from normal Solidity, and it has to be done differently with FHE. But truly, once those concepts are grasped and you like have a clear view of when and how they need to be implemented, that becomes really easy.
Mm-hmm. Okay, thank you so much. Okay. Change. For sure. Okay, so it's one more question. Like I think like maybe builders and also like Phoenix team is interested in this question maybe. Like where do you see the biggest commercial opportunity for Phoenix?
Commercial opportunity.
Yes, after they build some nice product and after, do you guys also like a support
Do we support, what was it? Sorry.
support like the builders after they build something? And after you Phoenix team also like support the teams like to do like some marketing or some like commercial opportunity.
Ah, yes, yes, yes. So we are working on an internal accelerator. This is to continue to support projects that are looking to go to mainnet, raise funding, do the whole thing. So the Phoenix team is very, very supportive here. We will help you with everything from the go-to-market and the pitch deck. We help with VC introductions. We'll help with the go-to-market angle in terms of, we'll help with airtime. We'll do some recorded calls. We'll publish a case study. We'll make sure that the co-marketing is done through all of our normal channels. Um, let's see, obviously from the technical side, if the code breaks, you have somebody from the Phoenix team jumping in to fix it. So yeah, I think during and after the build, there are a lot of opportunities to continue engaging with the team and really take the project to the next level. And yeah, I'm happy to share more information about anything we have in the works there as well.
Okay, thank you so much. Also, like Akindo, we have a deal room. So after like a build-a-thon, if there is a really nice product, we also select the teams, top teams, and we match with our partner VCs to give them like really good opportunity to get fundraise and like make them to become a real startup. So if you join this build-a-thon, please like make a really good product so we can see the future, maybe unicorn startup in the end. Okay, so guys, like, do you have any more questions? I'm looking at the live chat now. Okay, this is interesting question. Like, maybe maybe it's difficult to answer for Lauren, but like, how do you stay motivated like while working with this new technology? Any advice?
Yeah, I mean, motivation is it's definitely an individual thing. It depends person to person, but I would say focus on the excitement, right? You are building with the technology that wasn't really feasible. Maybe, I mean, honestly, like 6 to 10 months ago, but years ago, this wasn't possible. In the early days of Ethereum, it wasn't possible. Like, you're building for a market that hasn't been touched yet, and the capabilities are endless. So I think focusing on all of the possibility instead of like the wow, this is hard to get started with, or like, oh wow, like this piece is challenging. I'm like, wow, I'm for the first time this project can be built, and I have the first mover advantage and the competitive advantage to be the one who brings this to life is really, really an exciting thing.
Hmm. Okay, I think like it's a great answer. So, oh, I think like Lauren already shared, but I think like some people are still wondering where to communicate with builders. Is it only Telegram channel?
Yeah, I think the Telegram channel is the best place.
Hmm.
Obviously, my calendar is public, so if you need a brainstorming session, you can find me there. But the Telegram chat is the quickest, the fastest, and the best way to get answers.
Yes, we already have a Phoenix Buildathon Telegram channel.
Mm.
So if you guys are new, please join the Telegram channel. Like it's on the live chat now. Okay. Uh, okay. Thank you so much. I think like I'll give one more question. So one more question. But what kind of like project would make you say this is exactly what we wanted? Like you already mentioned like RWA, like DeFi, but like just personally, like what kind of projects are you are really interested in?
Oh, that's a hard one because the project that's going to make me say that I haven't even thought of yet. It's going to be
Mm-hmm,
something that blows my mind and we're like, oh my goodness, this is something like it makes so much sense, but it never even crossed my mind. So it's hard to say now, but yeah, really focusing on the novel markets, something that does solve a very clear problem. Anything like that, we're going to be like, oh wow, can't believe this didn't already exist.
mm-hmm,
um, yeah, I'm trying to think of like more specifics here, but yeah, like I mentioned, I think anything agentic is a really, really exciting open space right now, and like most of what we see in that category we'll be excited about. I think there's a huge opportunity for using FHE for aggregated data analytics. This, for some reason, like it's a little bit less, sexy than a private prediction market, but I think it's extremely useful and, surprisingly not built yet. So that I
mm-hmm,
would like to see, like anything leveraging data. Let's see. Yeah, and honestly, as much as we've seen, a lot of strong DeFi projects, I think seeing cleaner UX flows around those DeFi projects. So like build the primitives, but make sure that the user experience is clean, that they're not bombarded with the overhead or the clunkiness, the functionality tension. Like to see that these were done in a way that's clean and doesn't add additional burden for integrating privacy will also be really exciting to us.
mm-hmm. Okay, thank you so much. I think it was a really difficult question. So then, are there any like types of submissions you want to avoid? Because I think we've done like a many buildathon, and since like the AI is getting bigger and bigger, like a lot of like projects actually using like vibe coding or AI. So like, do you have like anything you're um concerning?
Yeah, we've seen like a number of vibe coded projects that end up with like really broken logic. So if you're
Mm-hmm.
gonna use AI, use it intelligently, train your models properly, like train it on the anti-patterns, make sure that you like put the thought into it beforehand because we can smell the AI code, and if it was just like, vibe coded in a day, then like it's unlikely to be a profitable startup in 6 months, right? Like you have to build the foundation and the infrastructure for the project that you want to grow and thrive, really. So definitely put the thought in beforehand. Like there's no shortage of planning that can be done around something like this. Really thinking about how it's going to look down the line, and that work really shows in the end result. So yeah, I mean, really just think about the idea, do your research, and see if what are the examples of this out in the open. Like, if you're wondering, has this been built before? Or, like, what did it look like when this was built? You can ask me, have you seen this use case before? What do you think of it? And like, we can kind of workshop creative angles for it. But yeah, I think anything that just like tacks privacy onto the top in like a not so meaningful way will, yeah.
Mm-hmm. Okay, got it. Understood. Okay, there are like two more questions, and after this question, we can, I think, wrap up. So the last two questions are prediction market. Would they be considered as a project as well? Prediction market.
Yeah, private prediction market is something we've seen a handful of times now. I think there's a clear angle there, so it would absolutely be an example of a project.
Mm-hmm. Okay. So the last question is there any way to do like open source contributions on Phoenix? Is there any structured open source program?
Um, a handful of our repos are open source, and we're open to PRs on those, like the templates and the awesome Phoenix repo with aggregate of resources. So yeah, some of those things absolutely, but the core contracts are closed for the most part.
Mm-hmm. Okay, thank you so much. Okay, Lauren, so thank you so much. Like, do you have any last word for this onboarding session?
No last words for me. Happy hacking, everybody. I'm super excited to see what gets built.
Mm-hmm. Okay, thank you so much. Okay, then thank you again, everyone, for joining today's session. It was great to hear directly from the Phoenix team, like DevRel engineer Lauren, and it was very great to learn more about the technology and the vision and the kinds of opportunities this opens up for builders. So, and as I mentioned, this is not just about the buildathon itself, and we also support like promising teams through our deal room, where standout projects can get further visibility and like potential connections to our partner VCs. So we are really excited to see what you build, and we hope today's session gave you a helpful starting point. So thanks again, everyone, and we look forward to seeing your submissions. Bye bye.
Thanks, everyone.
Thank you.
Okay, thank you so much for great, yeah, workshop. So I